right, so you should be able to see my screen now. All right, so there are a couple of key features in HTML5 that make it possible to deliver a user experience to your users in the browser when they don't have a connection to the internet. The first, and arguably the most useful, is web storage. One major difference between cookies and local storage is that there's no HTTP overhead. The information that is stored in local storage does not get transmitted to the server the way it does with cookies, so there's no additional bandwidth constraints, which on mobile can actually be significant. It's a great place to store user preferences and other bits of application state, this kind of thing. Great way to add convenience for your users. It's probably not the best place to store massive amounts of data or record tabular style data, and we'll talk about some approaches for that later. But it's a great little area for basic settings and application state and that kind of thing. Now, local storage has a sort of sibling called session storage, which is the same, but it is tab specific or window specific. So if you close, so as long as someone has the tab that they originally created open, they can continue to access that data, and then when the tab is closed, it will be thrown away. So it's good for, maybe for sensitive data. Let's say you had a banking website and you wanted to store, I don't know, some kind of convenience information for quick access on the client side. Once the user closes, as long as the user closes that window, then that information will be thrown away. Another huge difference between cookies and local storage, I'll refer to local and session storage jointly as local storage. The one big difference is that the syntax is very, very simple. You've got basically two approaches. The first you can see here is local storage.setItem, and then you would say, in this case, foo is the name of the bit of data, and bar would be the value. You can also use object notation. So local storage.foo equals bar is basically the same thing. Of course, in that case, you have to make sure that your value names are valid JavaScript identifiers, but you can use that approach. I will point out that it is recommended to use the set item style because you can add hooks into that programmatically if you wanted to. You could extend that set item method, or you could potentially even provide an override function later. So it's a little bit more future-proof to use the set item approach instead of the more simple dot notation. As you can see, get is very simple as well. You just pass in the parameter of the value that you want to get, and it is returned to the variable. So here's a list of the different options for local storage. You can set, get, and remove items. You can get a value at a key, and you can clear, which just nukes the local storage completely. Okay. So very important to note that the data that is stored in local storage is just strings. So if you want to do something like store an integer in there, which you're then going to retrieve and increment, let's say, or do math on it, you have to run parseInt to convert it back from a string to an integer. If you want to store a JavaScript object, which is extremely common in practice, you want to use stringify and parse to store and retrieve it. So, it's often helpful in the real world to set up a simple little wrapper function that uses local storage to handle these things for you, and you just use like a generic get and set, and it'll go through and stringify and parse any JSON or whatever types of values that you're passing in. Just check the type and store it appropriately and retrieve it appropriately. Again, in practice, it's very common to maintain maybe even a local copy of some data you retrieve, some JSON data you retrieved from a remote web server or application state in a large JavaScript object, and then just keep storing and retrieving that in local storage. Very convenient. Scope is important to note. It's similar to cross-site scripting in its scope. You've got the same origin policy in effect. So the values that you store in local storage will be available to any page that is loaded using the same protocol on the same host, including subdomain, and the same port. Outside of that, there's not any real security to local storage. There's no built-in way to encrypt the local data. So it's the kind of thing that you probably don't want to store sensitive data there in the event that you had maybe include some other JavaScript in your page from another website or a rogue website or what have you. But if you were storing something like a password, it would be, unless you did something about it, it would be in plain text and would potentially be vulnerable to cross-site scripting attacks and this same sort of internet security issues that we have everywhere else with cookies, for example. So you definitely want to keep that in mind. The support for local storage, this is probably my favorite part of it, is very good. As you can see here in the green areas, basically every browser supports it, with the exception of Opera Mini, which is no real surprise. Opera Mini is not really that kind of a browser, but desktops and full-featured mobile browsers fully support local storage, and you can feel free to use it. So there are a couple of things I want to show you, I want to demonstrate about local storage and, in fact, the differences between local and session storage, and give you a feel for the ease with which you can use it, and also get you familiarized with the example files that I'll give you a download link later for the example files. Okay, so in the first example, I want to demonstrate a comparison of the difference between a regular JavaScript variable, session storage, which is tab specific, and local storage, which is not tab specific. First, we'll look at the source code here. Really, in the actual body of the HTML, there's really only three things. There's a button that you can use to increment your variables, and there is another button that allows us to start over, and there's just a holding element where we're going to print out these logs so you guys can all see it. And in the head of the document, where all the interesting stuff is, I'm going to walk you through this sort of quickly. Initially we've got a myCount variable. It's just a regular JavaScript variable. So every time I refresh the page, it's going to be blown away. So I'll just initialize it to 0 on page load. Then I've got local storage version of the same variable. And it's worth pointing out that there's no, there's namespacing in place here, so you can use the same variable name without fear of overwriting it or any kind of conflict. And what I have to do here, since in lines 16 through 18, because local storage is persistent, when someone loads the page, I don't know necessarily if they've been here before. If they have been here before, then local storage.myCount is going to be defined, and I'm not going to want to initialize it to 0. If they have not been here before, I do want to initialize it to 0. And same for session storage on lines 19 through 21. I want to initialize it to 0 if this is the first time they've swung by. Okay, let me also point out that you can set these to an integer, but when they go into local storage, they become a string, and I'm going to be parsing those on the way back out, which we'll look at in a second. All right. So as you can see in this button down here, I have, I'm just saying on click, call this increment variables function. What that looks like here is this. So it just adds basically a log to the screen so we can see the value of each variable. Each time I click it, it adds 1. Look at the code for that. First, I just increment the JavaScript variable. with a plus plus. And then I want to increment the storage variables, web storage variables. So the session storage, you can see here I'm using parse int to get the value and then add 1 to it. And same with local storage. So no great shakes there, just pointing out that you do have to use this parse int, otherwise it would just keep doing string concatenation. If it started at 0, then it would be 0, 1, and 0, 1, 1, and 0, 1, 1, 1 every time we added a 1 to it. So that's really all this function does, and then we update the display, which is what writes it out to the screen. Nothing really interesting there. It just the main portion of that is right there, lines 56 through 66, where I'm just appending a log message, creating and appending a log message to the screen. All right. So the magic of this is that when I refresh this window, it's, nope, watch the last line where the values are all up to 3. When I refresh the window, the JavaScript variable disappears, of course. If you're familiar with JavaScript, that should not be surprising. The session storage is persistent. It stays there, and the local storage stays there as well. They're both at 3 where I left them. So now when this page loaded, when I just refreshed it, these ifs evaluated to false. So these lines were skipped, and the local and session storage variables were not reset to 0. All right. If I increment more, it's just going to keep going up like so. Let's go up to 9. All right, now I'm going to open a new tab. And let's do this like so. And let's give ourselves some room here. Then we're going to compare these two tabs and note the difference. So if you can see over here, we've got, this is the original tab on the left-hand side. We've got variable equals 0, session storage equals 9, local storage equals 9. On the right-hand side, we have a new tab, and you can see that the difference is that session storage has started over. So this page knows nothing about session storage on this page. I can keep refreshing this page. It's going to stay the same. That 9, that session storage equals 9, is going to stay there because this page knows about it. Now, if I increment this page, everything's going to go up by 1, page on the left, which makes sense. If I increment the right-hand page, JavaScript variable goes up by 1, which makes sense. Session storage goes up by 1, which makes sense. Local storage goes up to 11 because 10 got used up over here. So since local storage is shared between the two tabs, it makes sense that they would increment. Increment together, essentially. So I also want to show you. I want to open the Chrome Developer Tools. And show you how you can get a view into these values. On the Resources tab of the Chrome Developer Tools, you can see these various items here. We've got local storage, session storage, application cache, databases, IndexedDB, etc. We want to look at the local storage at the moment. And here's that my count variable that I set. It's up to 15 because of the other window that I just closed. So if I refresh this page, see that reflected there. And if we look at session storage, we should see a 12, which we do. And again, that is specific to this window. And if I open a new tab, it would be 0 in the new tab. All right. So there's one more thing to note here. Let's reset this. One more thing to note here, which is that since local storage is shared across multiple tabs, it's possible for the display to get out of sync, as we just saw there. So if I incremented something in one tab, repeatedly, the other tab would not necessarily know that. So imagine something like, I don't know, let's say something like an email inbox, and in one tab I am removing items, and then in the other tab I'm still displaying the same count of items because it hasn't updated, and we're storing that in local storage. What you can do is attach event listeners to the storage event, and have that update any non-visible tabs. So what that looks like is right here. It's commented out so you can play with it in the example files. But here I'm adding an event listener to the storage event on line 77, and I'm calling the update display function that we already have. So when the window does update, then, when the value is updated in any tab, all the other tabs will receive this event and update the display. It won't happen on the active window because that's the window that initiated the event. That's a little counterintuitive at first, but it's good that it's set up like that. So this first line in 77 is the raw JavaScript version of how you would write that, and then on 78 is how you would do it with jQuery. So you can play with that at home for homework. And from there we'll move on. Back to slides. All right, so next, that was local storage. Technically, it's called web storage. Local storage and session storage is collectively called web storage. And we'll move on from there to WebSQL Database. This is literally a client-side SQL database in the browser. The support for this is not as good as local storage, but I'll address that in a little bit. And I often also get questions about whether or not this really is HTML5. And technically, the WebSQL Database, while it was at one time part of the HTML5 spec, it's been moved into its own spec, and it's frozen waiting for someone to implement it with something besides SQLite, so there's not a dependency on SQLite. I don't want to scare you with that. I usually get that question. The WebSQL Database has been implemented in several major browsers, and it is extremely useful, and it's something that is not going to go away just because it was moved into its own spec. So it is something that you can use, and it's something that I use in client projects. So like I said, it's a client-side SQL database. You access it through a JavaScript API, and it's, like I said, wrapper around SQLite, and it's particularly good for performance enhancements, but it can serve you well in an offline capacity as well. The syntax is a little wonky, which is maybe my only complaint about it, other than the lack of support in a couple of browsers. But syntax is a little wonky, but you get used to it because there's not that much. There's really not that much to it. It's very the same all the time. It's just kind of weird. You do need to know SQL, of course, because you're going to be talking directly to the SQLite database. On this screen, the piece to pay attention to is the first part, the first 4 lines or 5 lines, where you're defining some variables, the short name of the database, which is what you'll use internally to talk to it, and then you can add a version number, which you can use for upgrades in the future. You can check version numbers and do your migrations from one database version to the next as you upgrade your web app. Then you give it a display name, which is the string that will be shown to the user in the event that the database needs to ask them a question. Specifically, there's a size limitation on the database, and if your application wants to exceed that limitation, which right now is 5 megabytes, the browser will throw a dialog saying that my database wants to increase its storage from 5 megabytes to 10 megabytes, yes or no. So they can approve or reject that change, and if they approve it, you get 5 more megabytes, and if they reject it, you'll get a SQL database, a WebSQL error that you can trap for. This max size on the 4th line, as far as I know, is not actually respected by anything. Browsers, you can't tell it, a huge number and automatically get a huge database sandbox. I I've yet to find anyone who knows whether or not, or knows why that's there or if it will ever be implemented, but I put it in to be on the safe side. Generally, I put it in at a size that I expect the database should not exceed. So if I think the database could never reasonably go over 10 megabytes, then I would put a value there in bytes to indicate that, but it's really more for, I suppose it's more for the developer who comes in behind you to know when things are getting out of control and when they aren't. Okay, once you have those 4 parameters defined, you call an open database request. And what that'll do is either open the database if it does exist, or it will create it if it doesn't exist. And you store a reference to that database. I'm storing a global reference in a JavaScript variable called DB. I could have inlined these strings as the parameters here. I just broke them out, so it's sort of self-describing for you. Okay, once we have the database, we can start sending transactions to it. Actually, it's on the next slide. Yeah. Everything you do in terms of communicating with the database happens in a transaction. You have to use transactions. If you're familiar with SQL programming, that means that you can send you can execute multiple SQL statements, and then if something goes wrong in, say, the last one, you can roll them all back in one fell swoop, so that the database doesn't end up in a malformed state where half the records you tried to write were written and the other half weren't. So that's nice. And then what you do when you call this transaction method of the database object, you pass in this callback that accepts the transaction object. So this is what I was talking about when it's a little bit weird. It's a little snake eating its tail-ish here. But this is the syntax. It's always the same syntax. So once you get used to this, or just have like a keyboard shortcut to enter this in for you, it becomes white noise after a while. And all you really need to worry about are the 4 lines in the center here. Okay, so the 4 lines in the center here are just, you've got 4 parameters into the transaction.executeSQL statement. First, you get the SQL statement, and it's what's called a prepared statement, where you enter a question mark for any application provided or user provided values that you want to insert into this statement. And for each question mark in the prepared statement, you provide an array element on the second parameter. So because there's one question mark here, that means that the next parameter is going to be an array with one element in it. You don't have to worry about escaping anything. You don't have to worry about data types. All of that is handled automatically with the prepared statement. So that's really convenient if you've done much SQL programming in the past. Escaping your user input can be tedious at best. So this is a nice advantage. Then the last 2 parameters are success function and a callback. A success callback and an error callback. And we'll look at these in more detail in the example. Okay, so that's what I just talked about. Okay, so scope. The scope here is the same as we saw with local storage. Same origin policy based on protocol, complete host name, and the port. In terms of support, as I warned, there is right now nothing in IE or Firefox, and I think Firefox or Mozilla it's pretty much safe to say that they are not going to implement it because they seem to prefer something called IndexedDB, which we'll touch on briefly today. IE, I guess it remains to be seen whether or not they're going to implement it. At one time, it seemed like they wouldn't. So what that means is you want to use you want to use the WebSQL database in a way that progressively enhances your web app in case it gets opened in something like IE or Firefox. You need to be able to still operate communicating with the server on the server side, but for people who are using Chrome, Safari, Opera, or Safari on iOS or Android, you can give those users an enhanced experience, potentially offline access. But you don't want to build your entire application unless you can control what browsers you're going to run in, which is sometimes the case, but not generally the case. Unless you can control which browsers your application is going to run in, you don't want to make the WebSQL database a requirement. So let's look at some example code. And open this in. Let me just point out before I pull this up that the 3 examples here that you'll get in the links at the end of the slides are an example of a contact list, and these examples 2, 3, and 4 are the exact same user interface implemented with different back-end client code. So the first one is implemented with web storage that we already looked at. The one that we're going to look at now is implemented with WebSQL Database. And the next one that I'll run through quickly is IndexedDB version. So they all look the same. When you load them, they'll all look the same in the browser, but sort of behind-the-scenes guts is different. All right, so this is kind of a lot of code to go through. It's not complicated. There's just a fair amount of things. So I'm gonna hit the high notes and let you play with it on your own. Here's what happens when you use this. Let's say I type in my name, and I create it. And then I'll do a couple others. And all right, so now I've got a few records, and when I refresh this, those are persistent. I am not talking to any server. This is all running locally. It's not even a web server involved here. I'm just opening it like a static file. I can search. It'll filter down like so, and I can delete. So normal database CRUD operations, totally and completely in the browser. I'll quickly show you. There's not really much to look at with the HTML portion. There's just a little UI for the buttons and fields, and each one calls a function that's in the JavaScript, which is the interesting area. So if we look at the JavaScript, there are functions for several different things: create, delete, find all, and then the data handler and the error handler are the 2 callback functions. Those are the 2 things I actually want to look at in a little bit more detail than the others because they're a little trickier. And then we'll look at the onload function. Let's start with the onload function. So when the window first loads, when the page first loads, first I just grab references to some of the elements on the screen so I can sort of shorthand my way to accessing their values. You could use jQuery here just as easily if you're more comfortable with that. And then on line 104, I start a try block to make sure that I've got open database as a function on the window object. If I don't, I'm probably in Firefox or some browser that doesn't support it. And in this case, I would just alert database is not supported. Your code would obviously not do that. It would do something a little bit more sophisticated, or it would just skip all of this stuff. Okay, so assuming that open database is supported, I've got those. I basically have the open database lines that we looked at in the slides. And then the first time through, I run when the page loads rather, I run a create table if not exists statement here, which, if this is the first time to the page, there's no table or anything. It's just a database. You need to put a table in it to hold the data you want. So here I create table if not. Lost you at error handlers. There's a couple of important things to note. I'll try and make up for lost time. When you execute a SQL statement, you want to provide an error handler in case something goes wrong. In practice, the only thing that really ever goes wrong is if the database asks for more space and the user says no. But otherwise, I've never encountered anything going wrong at a runtime. knock on wood. At any rate, you want to provide an error handler, and in this case, on line 94, I'm providing possibly the simplest error handler ever, which just, it accepts the transaction and the error itself. And in this case, I'm just alerting the user that there was some kind of error and inlining the message and code from the error object to give them an idea of what happened. Like I said, this is usually, you wouldn't normally do this. I usually leave a line like this in while I'm debugging or developing, and sometimes I'll catch myself fat-fingering an item, a field name or something like that, and I'll get an error. But generally, there's no errors. Generally, you're just working in a single-user environment on a local hard drive, so it's usually not that much to worry about. However, you do need to be aware of the fact that the return value of the error handler function is significant. If you return true, the transaction will be rolled back, and you'll be in the state that the database will be in the state it was in before the transaction threw an error. If you think that the error is not important, you inspect the code for some reason, and you think you can either recover from it or it's not a big deal, you can return false from this, and the transaction will proceed. This really only matters if you're executing multiple SQL statements inside of a transaction, which for client-side programming hasn't been something that I've had to do very often, unlike server-side, because it's a very simple context compared to old-school server-side web database development. So at any rate, you just want to remember that if you want your transaction to roll back, you need to return true from the error handler. So quickly, I'm going to show you what the data handler function does. And when you call a SQL statement, or when you execute a SQL statement that returns values from the database or returns rows from the database, those rows get passed into the data handler, and the data handler can decide what to do with those. In my example here, when someone does a search for nothing, that basically means find all the records in the database, and it executes this SQL statement. Select all from person, order by first name, last name. There are no parameters or anything, but when those records are retrieved, returned to the data handler, this function down here gets called, starting on line 69. You get the transaction in case you need to interact with that inside of the data handler. Literally never done that personally, so your mileage may vary, but you can do it. The important piece is this results parameter. So in this function, I'm just clearing out some fields from the user interface, no big deal there. But then I process the results. So what I want to do is essentially loop through the rows and create, table rows, some HTML. So what I do is on line 77, I initialize an empty variable called HTML, and then I check to see that the results.rows.length is greater than 0, essentially. If it's 0, then my HTML is just no records found. As you can see, I'll give you an example of that shortly. But if length is greater than 0, then I create some HTML, I open a table, I add a header row, and then I for each my way through the results, creating rows. One interesting thing to note in here, this is basically a garden variety for loop. Interesting thing to note is on line 83, where I access the current row that I'm on in the loop with an item function, not an array. So the rows object has a function called item that accepts, or a method called item which accepts an index, positional index of where in the array it is. So you can grab that out of there using the item function. When I first saw this, I thought it was a typo and that it should have been, like that, or maybe even rows I like that. But rows is not a simple array. It's a more complex object. So this is actually the correct syntax. Once you've got that row captured, you can access the elements of that array. It's really an object. You access the elements using the column names that you defined when you created the table. So this first name camel case first name is exactly how I created that first name column in the database. That's the exact same syntax. You could use dot notation like so if your column names are valid JavaScript identifiers, but I prefer not to worry about that, and I just use the quoted form. Okay, so because of the interruption, we've only got 10 minutes left. So what I'm going to do is soldier on, and if we see what we can do. Let's jump back to slides and get our bearings. So next is IndexedDB, and this one I'm not going to go as in-depth on the example. You can do that at your leisure when I give you the link. The thing with IndexedDB is that it's extremely promising, but it's supported in so few browsers, well, we'll get to that in a second. It doesn't have as much support, so I'm not going to spend as much time talking about it right now. But the concept is that IndexedDB is a client-side NoSQL data store. Transactions are required, just like SQL Database. There are asynchronous and synchronous APIs, although I don't believe the synchronous one is actually implemented anywhere. So when you're working with IndexedDB, it's a little bit of callback soup. You never really know when something happens. You just register handlers to respond when something does eventually happen. So it's sort of like a combination of web storage and WebSQL in terms of syntax and the way it feels. Scope is the same as before, the other two things that we've looked at. And if you look at the support, the reason why I haven't really spent much time with IndexedDB is because there's no mobile support. So for me, that's a deal breaker. The reason why I do like WebSQL Database is because it does have strong mobile support, and these days if you don't have, mobile is where you need all of the progressive enhancement and performance improvements, much more so than the desktop. IndexedDB is a little bit of a non-starter for me right now, but it's definitely something to keep your eye on for the future. I'm just going to quickly show some example code here. Again, visually, it's going to look the same as the previous examples. This one. So this is what it looks like when no records are found. And it's going to behave exactly the same. The exercise really is to show you the level of complexity with implementing each of these different styles of storage. If we look at this code, it's the longest of the ones that we've looked at today. Same HTML, exactly the same HTML section, but let's see if I can collapse these a little bit for you. But and I've got the same functions: create person, delete person, find all, and render results. It's slightly different, but it's the same concept. And at load time, we initialize the database. We have to deal with some cross-browser issues here. Kind of normalize the interface depending on what browser we're in, and then we connect to the database, et cetera, et cetera. Like I said, I'm not going to go through this in detail right now. You're welcome to do so on your own in the example files. But like I said, until it's supported on mobile, it's really not that useful, in my opinion. So hopefully it will be implemented. It is powerful and has some cool, unique features. So I'm looking forward to the day when it is implemented on mobile. In the meantime, I think it's something to keep our eyes on. All right, so we've got 7 minutes to talk about offline app cache, which is not enough time. So what I'm going to do is hit the high notes, like I said before. The concept of an offline app cache, if you're not familiar with it, is that It allows you to store static assets on the client side. So it's kind of like regular caching, but on steroids. It's great for things like HTML, CSS, and JavaScript that don't change all that often. And in addition to allowing offline support, it can drastically increase performance because resources are retrieved from the local cache even when the user agent is online. So that's both good and bad. It's good for performance, but it's bad if you're updating your website a lot because they don't, people won't see updates unless you remember to update your manifest. Speaking of the manifest, the way that this works is that you literally list your URLs to your static assets in a text file on your web server. You want to serve that with the text cache manifest MIME type, and then you reference that manifest inside the open HTML tag in your pages. So it's actually kind of straightforward. The trickiest part being probably getting the MIME type set up on your web server. If you're not familiar with configuring your web server, that can be a little bit of a learning curve. And in fact, some people on shared hosts aren't allowed to use htaccess files or what have you they just don't have access to control that sort of thing. So that can be a problem, and in fact, they're just talking about removing that from the spec, but it is still required in all the browser implementations currently. Cache manifest can be a little tricky to debug because we're all used to getting the live files from the server all the time. Sometimes regular caching can be frustrating. You change your CSS file, it doesn't make it through to your browser because the browser's accessing a cache copy. Well, that gets a lot worse with cache manifest because it can be very difficult to know if you're viewing the files you think you're viewing. So debugging is a big deal here. There are three main ways to debug. One is to use the JavaScript API to inspect what's happening in real time. Another is in the Chrome browser, you can inspect the app cache internals, which I'll show you because that's probably the easiest, most useful tool. And then the sort of proof in the pudding is if you log into your server, SSH into your server, your web server, and tail F your log, you can actually watch the requests in real time. So if you have a page that, it's got an HTML page, and in that page it's got an image, a style sheet, a CSS file, and some other linked things, and it has a manifest. When you refresh that page, you should see no requests. Your web server should receive no requests for any of those assets. You should only see a request for the manifest itself. And if the manifest has not changed since the last time the browser accessed it, then you will see no more. The browser will make no more requests, and it will retrieve all of the static assets from your browser locally. So pretty crazy. So the scope is a little bit relaxed compared to the other things we've looked at today, in that the same origin policy is only in effect if you're using HTTPS. But otherwise, you can include items from other domains. So, for example, jQuery from Google CDN, you could put that in your manifest. Support is quite good, as you can see here. It's implemented almost across the board, and it's one of those things that if it doesn't work, it fails gracefully, and the browser just requests things from where it would normally request them. If the browser is a little more advanced, then it will grab things locally, and your users will benefit from that. So I'm going to quickly show you what a manifest looks like. A couple of different examples that begin simply and increase in complexity. First, here's an HTML page, a regular HTML page that you might have on your web server. Looks like this. It's got a couple of images. It's got a style sheet and JavaScript included. But the thing you want to note is up here on line 2 in the HTML, I've got an attribute on my HTML that says manifest equals demo.manifest. And that is a relative URL from the location of this index file to this file right here, the demo manifest. It could be an absolute URL if you prefer, and you have your pages nested all over the place. Inside of this manifest, there are sections to a manifest file. A couple things are required. First, you have to have exactly this line at the beginning, cache manifest with no spaces, and a line return. This is a comment, and it's helpful to have maybe even you insert like your last updated date or a version number here, because when the browsers check the manifest in the future, they're going to look for any changes inside of the file, and if there have been changes inside of the manifest file, then it's going to re-download all of the assets that are listed in that file. The browser does not check things like file time, modified, or anything like that. Actually have to change the inside of the contents of the manifest file for it to update. So this section here, this header cache colon no space, is a section where you list out stuff that you want to be served from the local cache. And this is extremely sticky. They stay in the local cache unless the user goes to some effort to delete them. So that's the simplest possible example. One drawback of something this simple is that you have to include all of the assets that are needed by the index.html page. If there's something in the index.html page that is not listed here, the entire thing will fail, and you won't be serving things from the local cache. To address that sort of an issue, you can, well, we'll address that in a second, but the next section is the network section, and this is a section where you explicitly say that there are certain items that you always want to request from the network. So if the user is offline, then you want to, it will be a broken image. It'll be like it doesn't exist. And since we've listed here, that'll work. It won't break the cache. And then a little bit more realistic example is where I've got a static section here, where these are the static assets that I want stored for offline use, or at all times. I want served from the local cache. Then I've got a fallback section where I can provide a fallback image that will be used in place of anything inside of an images directory over here in the event that the user is offline. So this fallback section gives you kind of an either-or mechanism where you can say, oh, if the user's online, then all URLs that lead into the images directory, I want those to be pulled from the server. If we can't reach the server, then I want you to just store this offline.jpg file locally and display that whenever the user is offline. And then finally, and this is a great trick, if you put an asterisk in this network section, what it'll do is say that for anything not listed above, it'll request it over the network. And there's a very interesting side effect of this that I want to point out, and then we'll probably have to wrap. But if we go to my website, I have to look at the source. I've got manifest equals site.appcache. And this is, I just set this up for today so you can see it. I sometimes use this, I sometimes don't on my live site. Depends on if I'm doing a lot of development, I'll remove it. But you can actually view this file in your browser by going to the URL you see here. But the important thing to note is that in Chrome, there is, oh, here it is already. There's this appcache internals. You can go to this URL, chrome://appcache internals. In fact, there are a whole bunch of Chrome URLs that are quite useful, but we're just going to look at this one. And you can see here that there was no application cache available, but now I just visited my site. So if I refresh this page, oh, hold on. Seem to have screwed it up. Let's see if we can. You go to Chrome URLs, you get a whole list of Chrome URLs. Go to appcache internals. There we go. So what this is showing me is any sites that I have a manifest for as far as this browser is concerned. And it tells me the size, when it was created, when it was updated, when it was accessed. And you can view entries and go in here and see that there are a master entry, which is the page that actually has the manifest included inside of it. So it's implicitly included in this list. Then you've got explicit entries that came from the manifest itself, the fallback, some more explicit ones, the manifest itself, and the last explicit one. These are organized alphabetically. So here is the cool side effect, and this is what I'll finish with, is that as I navigate around this site, by virtue of the fact that this page has the manifest included in the header, right here, it's implicitly added to the cache. So I don't have to list every single page of my site, every single top-level page. I can just, it just is added implicitly by me adding that to my site-wide header. So if I refresh this, we should see a master entry added to this page, master entry being one that is added because it has a link to the manifest inside of it implicitly. So this is really useful. You can imagine on a site like, say, Wikipedia, if you're browsing around, you wouldn't be able to list every single asset on Wikipedia in an app cache, and probably the user only cares about the pages that he or she has been visiting recently. So implicitly, those will all still be available offline as they browse around. The act of browsing will cache them locally. So what that means is I can't show you this, or you wouldn't be able to see my screen. But if I shut off my wireless connection, I would still be able to browse these two pages that I visited while the app cache was in effect. And the other pages would show up. The other pages would display this offline.php page, which says something like, whoops, it looks like you're offline and this page isn't stored in your cache. So I'm afraid I'm going to have to wrap there. I'm sorry that we had audio difficulties, but if you want to, if anybody who wants to stay on wants to ask questions, I'd be happy to answer them. And you can always reach me on Twitter back at jonathanstark.com. Actually, I have to show you. All right. So if with that, I'll pass it back to Yaz. Like I said, I'll stay on as for maybe 10 more minutes if people want to ask questions.
Perfect. Jonathan, thanks so much for a great presentation. We do have several questions that have come in, and folks, we're going to take as many questions as we have time for, and we'll just start in the order they came in. We do have a question here from Ravisara, and they ask, is it possible to get an offline HTML5 app to start at boot time of a mobile OS like Android or iOS? Can you get the end user to initiate this after perhaps he responds to a dialog box asking whether to do so?
To launch at boot time? Who boots their phone? I think I'm not sure I understand that question, but I think the answer is no. On iOS anyway, I can't think of any. It sounds like a kind of like auto launch at login type of request. Not aware of anything on iOS that does that. Android's open season. You could probably, create a ROM that did that, but I've never heard of anything that did that. It'd probably be easy. There might be another. If I understood what the problem the person was trying to solve was, maybe there'd be another way to do it. But one of the things with apps that web apps that are running in a browser is that they run in a sandbox. They only have certain powers. They can't really interact with the OS. That if you wanted to create an app with HTML, CSS, and JavaScript and have it interact with the OS and maybe on Android receive intent, that kind of thing, or interact with the camera or the file system, then you could use like a phone gap style approach where you wrap the HTML, CSS, and JavaScript in a native wrapper, install it locally on the device, and then you get heightened permissions. I'm not sure if that would get you where you want to go, but it might be worth looking into.
Great, thanks, Jonathan. Just real quick, we do have several people asking, where can they get a copy of your files or the source code that you showed today?
Oh, yeah, sorry. If you go to, can I share my screen again?
Sure.
Okay. Let me know when you can see it.
It's coming up right now. Folks, if you can see Jonathan's screen still, he's going to give you information on how to get the files he showed you today.
Yeah,
Yep. So those are, you can actually play with those live right there at jonathanstark.com/lab/offline, and they're all self-contained files, so you can just save the source locally or just play with them on my site. But yeah, if you want to edit them, you can just save the source and open it locally.
Perfect.
So
all right. Question.
Yeah, go ahead.
Question from Bjorn. Sorry to cut you off there. Bjorn would like to know, what tools do you use for rearranging the windows?
Oh, that's a Mac OS plugin called Moom, M-O-O-M, and I couldn't live without it. Highly recommended.
Great, thanks. And we have a question from Chuck. What development tools environment do you recommend to get started creating apps?
That's a big question, and it's different. It depends on how your brain works, really. Some people like a WYSIWYG editor, and some people prefer a text editor. I'm a text editor kind of guy, so I use TextMate and Chrome Desktop for virtually all of my development. iOS 6 and Safari 6 have some really, really compelling new remote debugging tools. So those are also worth looking into when those are released. I think it's supposed to be in the fall. Or if you're an iOS or Mac developer, you can get access to those things now. And I believe that's not under NDA because they talked about it at the WWDC. So hopefully I'm not getting myself in trouble. But generally, I am 90% of the time just in TextMate with Chrome open, and I'm developing right there. And the Chrome developer tools are incredibly powerful. They allow you to beautify your JavaScript, stepwise JavaScript debugging. You can edit HTML, CSS, and JavaScript on the fly and then save the files out. So really a text editor in Chrome is the way I go. There are some WYSIWYG tools. I think there's one from Sencha called Animator, which I think creates interactive sort of HTML-based interfaces, but I'm not really a WYSIWYG guy. Like you might want to look into Sencha Animator. I think Adobe's got some new tools too, but I'm not super familiar with it.
Thank you. Folks, just time for one or two more questions here. Question from Dom. Dom would like to know, is the SQL/NoSQL implemented as an in-memory database, or will the data persist from session to session?
It's implemented physically on your disk, so it will persist session to session. I don't think I showed because I was trying to go fast. If you look in the developer tools, you can actually inspect the local database. I need to open the file. Hold on, I'll show it to you. WebSQL database. All right, so this is the WebSQL database example. If I open up the developer tools, you'll see the database right here. It's empty right now. And as I refresh the page, it will stay there. It stays there unless someone physically deletes it from this window. You can actually, in fact, click on the database itself and issue select statements directly or updates or insert deletes. People and actually run queries right there in the window. So the Chrome developer tools are well worth looking into if you're doing a lot of web development. Kind of like Firebug, but I like it even better than Firebug, so definitely worth checking out. But yeah, this is persistent. It's on your disk. If you search your local hard drive, you will find it. It's buried in application settings on the Mac, application settings, library, Google, Chrome, yada yada yada. But you can actually find this MySQL database. The SQLite database on your hard drive.
Perfect. And our final question that we have time for today is from Alberto, and he asks, do we have to use browser detection to decide which backend to run?
No, you can use something like Modernizer to feature detect. In the WebSQL database example, you may have noticed that there is a quick check, simple check to see if window.database exists or window.openDatabase exists, and if it doesn't, you could do something smart there. You could use something like LawnChair, which is a database abstraction layer written by Brian LaRue from PhoneGap, and Adobe, PhoneGap, Adobe, wherever he is now. And what that does is it abstracts the concept so that you can plug in different backend, what he calls adapters, so that it uses whatever solution exists. There's also an example, if you're familiar with the term polyfills, Remy Sharp wrote a polyfill for local storage that I've included in the download for this, or in the directory for this. So if you go to storage.js, you'll see an example of a polyfill for local storage. Even though that's very well supported in modern browsers, you can add this if you're nervous or you need even better support, or you know you're going to have old browsers. So what this does is it fakes local storage using cookies.
Perfect. With that then,
Yeah.
Jonathan, we're going to say a very big thank you to you for presenting yet another outstanding webcast, for sharing all your knowledge and expertise with us. Your hands-on presentations just are so great, and our audience really enjoys them, so we thank you. We thank all of our attendees today and hope you've benefited from today's event.